everyone. I'm presenting our work, Multimodal Feature Selection for Detecting Mothers' Depression in Dyadic Interactions with their adolescent offspring. Parents with recurrent depression are a significant risk to their children. Hence, there is a need to investigate history of depression among mothers for the developmental outcomes in children. Until now, we lacked relevant datasets. Existing datasets are limited to interactions between patient therapist, interaction with virtual agent, or reading of tasks. We introduce a dataset with 180 low-income mother-child dyadic interactions aimed at problem solving. Audiovisual information during the interaction was recorded and 152 were transcribed. 75 of these dyads form the depressed group, that is, mothers with a history of treatment for depression and current symptomology. The non-depressed group is mothers with no history of treatment and no current symptoms. We use mother features from action units, face and head dynamics, speech behavior, and verbal features. The time series features were summarized as mean, variance, standard deviation, interquartile range, minimum, and maximum. De-identified multimodal features will be made available to qualified researchers pending IRB approval. Our action unit features consist of intensity for AUs 6, 10, 12, 14, and 6 plus 12. Similarly, likelihood, duration, and frequency of occurrence for AUs 1, 2, 4, 7, 15, 17, 23, and 24. The face and head dynamics consist of displacement, velocity, and acceleration along roll, pitch, and yaw for head pose, and similarly for facial landmarks. Duration of head orientation was also accounted for through orientation along left or right, up or down, clockwise or anti-clockwise. Mean duration of head aversion along with rate of change of head orientation were also used. To capture depression effect on eye activity, distance between eyelids, eye closure duration, and blinking rate were also used. Manually segmented utterances were used to define inter-individual pauses and overlaps that form a speech behavior. Duration of the pauses and overlaps along with their rate together with the spoken duration of mother were used. The spoken words from the transcription were run through LIWC for word embeddings that form our verbal features. Our classification setup consists of SVM with linear and polynomial kernels and cost of misclassification. We use grid search with leave one subject out cross validation to report accuracy, positive and negative agreements. Our multimodal approach is the early fusion of modalities. Because of the large number of features we use, there is a possibility of large correlation between features. We use variance inflation factor to avoid this correlation, where features with more new information are preserved as an outcome. Shapley values for a given feature is a weighted average of differences in the prediction, the presence, and absence of feature. We use Shapley values to rank the features based on their contribution to the task. Our experimental setup consists of multiple steps. We first perform collinearity correction through variance inflation factor to reduce feature redundancy on each unimodal setting. We then rank the features based on their contribution to the top K features based on the Shapley analysis. We finally build a model to predict using these top K Shapley features. The bar chart shows accuracy of different modalities and the multimodal fusion in the baseline with no feature selection setting, features after collinearity correction through VIF, using Shapley on baseline setting, and using Shapley together with the variance inflation factor. The numbers in each bar show the number of features. We notice that the order of performance follows speech behavior, face and head dynamics, action units, and verbal features in all settings. With no feature selection, all modalities performed better than chance. Speech behavior reduced the number of collinearity correction reduced the number of features noticeably in face and head dynamics and action units. This also resulted in accuracy improvement. When Shapley ranked features with no feature selection were used, we achieved 79% accuracy with K is equal to 85 features. However, when Shapley ranked features from collinearity correction were used, we achieved 78% accuracy with K is equal to 15 features. K was chosen using cross validation. We investigate the Shapley outcome from the best performing multimodal fusion. In speech behavior, we noticed that duration of the mother's speech was lower in depressed group than non-depressed group. Similarly, in face and head dynamics, the yaw velocity and acceleration were lower, while rho velocity and acceleration were higher. Reduced intensity of AU12 positive affect and AU6 were observed in depressed group. The best performing multimodal set, the best performing verbal modality shows that depressed mothers tend to use more negations and comparisons and exhibit lower capability and analytic capabilities. Focus on past, informal language usage, and usage of numbers was also lower in depressed group. Our results show the contribution of variety of modalities for depression prediction. Collinearity correction with Shapley performance gave Shap- collinearity correction with Shapley gave best performance of 78% with only 15 multimodal features. The distribution of features show that 6 out of 15 are from verbal modality, 5 out of 15 are from face and head dynamics. Action units contribute 3, while speech behavior contributes 1. We introduced a new dataset in novel context of mother-child interactions for depression detection. Our modality-specific findings suggest that depressed mothers exhibit a less intense smiles, lower head velocity, reduced focus on past, and are less talkative. Comparing the results with clinical interview setting, we found that positive affect decreases in depressed individuals in both mother-child interactions and clinical interview setting. Head velocity decreases with depression in both contexts. Focus on past is lower in both mother-child and clinical settings. Mother talkativeness is lower in our dataset, but no comparable literature from clinical interview setting was found. Scan the QR code for more details and the paper. Thank you very much.